Alright, so I'm trying to build a Newman Motor generator. Alright, well, I got rid of these materials, put them down here. Okay, so I'm not totally finished with the machine, but what I have done, earlier I just had a 9-volt battery here. This this thing here connects to that. Okay, it goes here, it's connecting to this, it went around this coil, etc., and it ended up here. Earlier I had this connected to this. So let's see and zoom out what happens when I connect it like this. Okay, you see that moves? So, but I don't got the commutator system right now. Basically, okay, this rod over here, okay, this came from this thing. Yeah, I got it from Radio Shack. It's some guy wire, steel guy wire. So, I mean, this is a really cheaper version. I got a bunch of strong magnets, 6 of them, and they seem to like this steel magnet. And, I mean, this is simple. This wire over here, I got it for like, I don't know, 30-something bucks, and it's about 500 feet. I got it from Lowe's, Home Improvement Centers. And here's the spool over here. You can see it's 14, I think, AWG. You can figure out what that means. So, and here's, I had 4 of the 9-volt batteries, and here's the 3 remaining things that came in this package. Alright, next act. Hello again. This is my new coil. It's made of RC25 wire. I just took it out of its spindle just through brute force, taking out the metal parts, the cardboard, whatever. So I hardly had to wind this up. I've divided this according to how I'm gonna connect these wires in series. This is split into 25 conductors, hence RC25. It's usually used for computers, but here, this 26 gauge wire, we're going to use it for our Newman motor. This is the one I just built a few days ago, and I thought maybe I should step it up. This one is 400 feet of wire divided into 8 wires, each 50 feet. Alright, and the black wire, the black casing is 50 feet. Now, this big conductor, okay, it has more volume. It has 25 conductors. This coil is, I heard, 100 feet long. 100 feet. Okay, that's kind of weird, but okay, 100 feet long. And if you have 100 feet multiplied by 25 conductors, for all of that 100 feet, then that's 2,500 feet. Now, this coil already comes in the sort of shape I wanted for my Newman motor, so that's good. It's a bit like tall, almost as tall as it is wide. So you got a sizable area of conductor, like, you know, like this, right? And compared to this, it's a whole bunch more conductor. As you can see, these tips, well, I guess you can't see it, but these tips just have a lot of conductor in them. So, alright, we're going to create our high inductance to resistance ratio to this coil. This is the old model. This is going to be the new model, and it's going to spin faster. Its inductance is probably going to be at least 6 times more than this, so its speed ought to be, or, well, its resistance, its inductance to resistance ratio, I don't know what it's going to be, but it ought to be stronger than this. It ought to be stronger than this. This has got to be stronger than this. Alright, we'll see if the theory works. Alright. shit! Welcome to the latest Newman Motor. We got these things moving around. Now I'm just gonna place them over here. See? Now I'm gonna take all of these. And I put this over here. Let's take one of these. So we got this wind.
final thing for me. I broke the bank, missing love.